Hello, welcome to the TechHub.training challenge solution video for Echo Empire's ambitious enterprise in Python. Today, we'll be learning how to use our knowledge of univariate statistics and our knowledge of Python to answer some questions the marketing director has about potentially changing their business model. By the end of this challenge, you'll be able to know more about Python as well as more about basic univariate statistics, including running a t-test at the very end. This is really cool analysis as it can help make Echo Empire make some decisions based on our findings. So let's jump in. So the first step of this challenge is to simply load the data and get familiar with it. The data dictionary provides very specific information about what each column of data represents. I won't be getting into that in this challenge here, but feel free to reference it as you're solving it, and that should be able to help you figure some things out. So the first thing that I've done is I've imported pandas, and then using read CSV, read the data in. And then this is something I always do when I have data, is I look at the types of data, and I also just kind of get an idea of what the first 5 rows look like using the df.head. So I'll go ahead and run that. So we can see there's some object data types. Explicit is a Boolean data type, so true or false. And we can also just kind of get an idea of what our data is looking like here. First 5 rows. Again, the data dictionary is more specific about what each of these numbers mean along with each of these values. Alright, so now we're going to do a little bit of cleaning up. So the second step asks us to change the duration to be in terms of minutes instead of milliseconds. So if we look here, we can see that it's in milliseconds here. What does 211,000 milliseconds tell us? Nothing. So there's multiple ways to go about this. The way that I chose to do it was to actually define a function called convert milliseconds that takes a millisecond number and converts it to a number of seconds and then minutes and then just returns the minutes. And that's simply because I didn't want to figure out the direct divide to get from milliseconds to minutes. So it's just easier for my brain to think about it like this, right? There's 1,000 milliseconds in a second, and then there's 60 seconds in 1 minute. And then I also rounded this to 2 decimal places because that's what the question asks us to do. And then what I did was I applied it to the data frame. So you just take that same column, duration ms, and apply it. So .apply, and then you put the function name here, and that applies it to that entire column. And then you can use the rename method to rename it. So just change it from duration ms to duration minutes, as the question says, and then I have this in place equals true to make sure that our data frame stays the same. So let me run that, and then if we check out what our data frame looks like now, we can see duration minutes is shown 3.52. So now we know that 211,000 milliseconds is 3.52 minutes. Who knew? All right, so step 3. What percentage of these songs are classified as pop? We want to save this to a variable called pop percentage in percentage form, rounded to 2 decimals. We need to keep in mind that a song can have multiple genres, and if one of those genres is pop, then that song should be classified as a pop song. So let's just take a look at the data and see what we're talking about here. So we pull up our data again. We go to the genre tab. We can see this one is a pop song. We can see this one is rock and a pop song, pop and a country song, rock and a metal, and then this is pop. So what we want to be able to do is we want each of these to count as a pop song. So this one that says rock and pop should be included as a pop song. So the idea is we're going to want to do some sort of looping to get an idea of which songs qualify as pop song and which ones do not. So here's how I chose to go about this. So first, I have this pop count variable to keep track of how many times pop appears. And then I just start a loop here. So for a value in the genre column. So just starting a for loop, and it'll loop through all of these genre values in our data frame. And then what I'm doing is I'm creating a list of genres, and I'm splitting on the comma and the space. That way, if there's a comma and a space here, it'll split that, and then the list will be both of those variables. So for example, this would have a list of 2 things, rock and pop. So then what I do is another loop. I loop through each value in that genre list, and if it's pop, then I increment this by 1. So this plus equals is just an easy way to increment 1. Another way to visualize what's happening with the +1 is just if you were to do pop count equals pop count +1, that's all this is doing. So something like that. So in this case, that's what it's doing. And then we'll get a total number of songs that are pop. And then to get the count of the songs, we simply can just take the song column here, which is kind of our primary key in this instance, which is why I used it. And then just simply count the songs. And then to get the percentage, it's just like normal math, right? You take the number of songs that were pop, and then divide it by the total, and then multiply it by 100, and we're also rounding to 2. And to get this percentage at the end, you just need to convert it to a string and then add that percentage symbol on it. And then we can print. So I'll go ahead and run this. So now we can see that 81.65% of the songs are pop songs. So next, the question asks, is pop the most common genre? So we need to be able to take our code here and run it against all of the unique genres that are in the data set. So what we need to do, and then the question points you to also define a function to help you do this. So all we need to do is convert this code into a function format. So I've done this here, genre percentage. So you'll notice all I did was I took pop count and changed it to genre count. This is just a general. But then other than that, this is all exactly the same, right? So this is just taking a genre value in genre list, and if that genre exists, then it's going to add 1 to it. This is another count, another percentage. And then I do have something a little bit different here in what it's returning. So what I chose to do was I chose to return just like a string that had the genre, followed by a colon and a space, and then the percentage of the songs in the database. You can choose to do this however you'd like. You just want to make sure that you're getting a list of percentages and they're able to tie out to which genre they belong to. So next, if we want to be able to apply this, we need to get a list of distinct genres. So again, you can do this a lot of different ways. What I did was I created a list called unique genres, and then I looped through the genre list. I did the same split as before, and then did a lot of this is similar code. So then I just said, if that genre is not already in unique genres, then I append it. And then if it is already in it, then it just moves on to the next one. And so then you get a list of unique genres. So, and then let's actually just pause and be able to see what this code here looks like. I just want to run just this unique genre so we can see what's happening here. So if we do this, and then let's print out our unique genres. Look at all these unique genres. So we can see they're all listed only once, which is what we want to see. And so then once we have that, all we need to do is just run it through this same function, because these genre values are going to plug into this, and we're just going to do a loop and run it through all of these. So in order to do that, this is the most efficient way to do that. It's what's called a list comprehension. What it does is it's just an easy way to just generate a list and print it. So what this is saying is run this function, so the genre percentage genre, for each genre in the unique genres list. And then you just kind of surround it by the lists brackets, and that'll just get you a list. If you're more familiar with for loops, this is another way to do it. You can just define another list and then just say for each genre in the unique genres, you're just going to run this function and you're going to append the result to the list, then print the list. For now, I'm just going to comment this out and focus on just this list comprehension, and then we can see what our results are. So now this is just a very easy way to see each genre and the percent that they show up. So 0.1% of the songs are jazz, 38.9% are hip hop, but we could clearly see that pop is by far the most popular genre, which answers our question. All right, let's go ahead and move on. So next, we need to calculate some statistics about the numeric variables the marketing director is specifically curious about: popularity, danceability, and tempo. And then we need to export a CSV file containing the mean, the median, the first and third quartiles that we can provide to the marketing director. Furthermore, the column names should be the four statistics, so the mean, median, first quartile, and third, and the numeric variable names should be the row labels. So there's lots of different ways to approach this. I anticipate seeing multiple ways of doing this in the comments for this challenge, but I will walk you through how I decided to do it in the solution. So first, I created this filtered data frame, which is just an easy way to just take that existing data frame and only filter it based on the 3 columns that we want to focus on. So in this case, I just limited it to just the list of the columns we want to focus on. And so then what I did is I created a new data frame for the statistics. And so what I did is I just did a pd.dataframe, which is just an easy way to create a data frame. And I set the columns equal to mean, median, Q1, and Q3, because that's what the questions ask or specify. And then the index I set to filterdf.columns. Now let me explain a little bit more about what this is doing. So let me I'll copy this up here for ease. And then let's look at filterdf first. So if we were to just run this, we can see that this is just the 3 columns we're going to focus on. So then if we uncomment this out, this might be a little bit easier to see. So the index I have set equal to filterdf.columns. What that's going to do is it's just going to take the columns of this, and that's going to become the row index or the row label. It's going to come down here, which is what we want. So now what I'm going to do is I'm just going to change this to the statsdf, and then we're just going to see what this looks like. So now we have our structure. We have a popularity, danceability, tempo, right down here, and we have our stats up here, and now we just need to populate it. So how do I do that? I did a for loop here, and now what I'm doing here is I'm using .loc, which is just a way to reference a specific cell in a data frame to populate another cell. So what's happening here? So what we're going to say is statsdf.loc col and mean. So we're looping through a column in the filtered data frame. So this is going back to the filtered data frame. So it's probably easier if I have the filtered df here to show what's happening here. Let me just pull that back up. So it's looping through each column in here. So let's just say popularity. So what it's going to do is it's going to find statsdf and find the popularity row and the mean column. Where those two intersect, it's going to set that into the mean of that column. So it's going to take the mean popularity and it's going to set that equal to that value in the data frame. So what this is doing is it's taking filtered df popularity, which gives you a series of popularities, and it's taking the average of that and putting it in the stats data frame. We're using the same logic to do median, Q1, and Q3. And then this is how you export. You just do the .toCSV method, and then I have requested stats.csv in my folder, and that's what it'll upload to. For the purposes of this tutorial, I won't export it, and instead I'll just display the result here so we can just see what it looks like. All right, let's go ahead and get rid of this, and let's run it. Perfect. So we've got mean, median, Q1, and Q3. So we can see here that there's lots of decimal places here. If you were to really turn in this report, you might want to consider rounding. So if you wanted to round, all you have to do is just go back into your for loop here and just round here. So you just do round and then just say 2 decimal places and then just do something like this for all 4 lines. I won't do it for the purposes of this challenge. I didn't ask you to, so I think you are fine just for the purposes of this challenge. If your file looks something like this, then you've done it right. All right, and then finally, we get to go to the marketing director's most pressing question: do people really care? So we're going to ask to make a graph using matplotlib. We're using a dual line graph where we're going to plot the relationship between the average popularity of explicit songs and non-explicit songs over time. And it's a little tricky because 1998 only has 1 year or 1 song in it. So for the purpose of the graph, we're going to exclude it because otherwise it would throw a lot of things off with the graph. So there's a lot of different ways, a ton of different ways actually, that you could approach doing this to get your X and Y values. I'm merely going to suggest what I did, but you could do something completely different. So first, what I did here was I just took back to the original data frame, so not counting the filtered or the stats or anything. I just went back to the original, and I just used the set function to get a distinct list of years. So let me just show you what I'm talking about. So if you were to do df.year, this will show you a list of years. What set does is it just only includes a year once, so it'll only get a list of years. So if you were to do, let's just simulate that here. Now you've got a set containing every year that's in the data set. So you've got 1998 through 2020. So that's what I did. So first I set that to a years variable. And then what I did was I used sorted and then also converted it to a list. Because if you remember in the hints, you can't use a set data type to populate a graph. So I converted it to a list using the list function. And then set that to itself. And then I just simply used the dot remove method to get rid of 1998. For the y values, it's a little bit trickier. What I did was I created two new data frames, explicit df and clean df, and all I did was I filtered on this explicit variable, this boolean, remember, boolean variable, and I basically said if it's explicit, I want a list of songs that are explicit and a list of songs that are clean. And then I did a group by here. This is probably going to be one of the hardest parts of this challenge. And so what I did was I took those explicit songs and did dot group by, and then what it does is you pass an argument on what you want it to group by. So in this case, I wanted to group by each year, and then I wanted it to do the analysis on popularity, and then I wanted the average of the popularity. So it's a little bit tricky to remember all these arguments in the group by, but if you've learned SQL and other things, you can kind of see some of the logic here and what's happening. So what it's going to do is it's going to take the explicit df and it's going to take all those popularities and average it by each year. So that's what's happening. And then I just do the same thing with the clean df. And then because we want to get rid of 1998, I just do a filter out of the explicit list because the challenge said it was an explicit. So all I did was I just said, okay, I want all the explicit pops where the index is not 1998. Now again, lots of different ways that you can do this. Before we jump into the graph though, I'm going to run this and kind of show you what this looks like. So if we were to print out explicit df, we can see this is just the normal songs where explicit is true. That's always going to be the case. There's not going to be any falses here. If we were to do clean df, we would see the same things except for false because these are clean. And then if we look at what the explicit pop one looks like, we can see how it's grouped by year here, and then it has values here. You'll notice this is not a data frame, this is a series. Because it's a series, the year is stored in the index, and because of that, that's why I did .index here to pull out the 1998. You can't refer to the year column if the year is the index. So instead, you just have to say, all right, I want all the ones where the index is not 1998. So now, and then I'll just, for the purposes of this, I'll say clean.pop so we can see what this looks like. All right, so now we have a list of popularities, average popularities by year for explicit and clean. So now let's plot it. So what I did is I just did plt.plot, and then by default, this is a line graph. So I didn't actually have to specify line graph here. And then what I did was I have the years, which we got from our x values, explicit and clean, pop, those are the group by ones. You have to add a label to each of these in order for the legend to work. And then I just added a marker and a marker size to make it more visible. You don't have to do that. Adding a title, labels, and then you do plt.legend is how you add your legend. So let's go ahead and plot the graph. I need to run this above first. So let me do that, and then let's plot our graph. All right, so let's do a little bit of interpretation. So the question asks, do you think the data confirms the marketing director's feelings on only wanting to host non-explicit songs? So we can see the blue is explicit and the orange is clean. Generally, over time, it looks like to me that explicit songs tend to be more popular with some exceptions, right? There's a few exceptions, but generally, explicit ones, the blue, tends to be higher than the orange. So I would argue this does not actually confirm the marketing director's popularity or thoughts. And I would probably also argue that he should not focus on clean songs only. He might not be as successful as he thinks. However, let's use some statistics to prove it. So the final question is asking you to do an independent samples t-test. So the idea with this is to get you introduced to statistics in Python by running one simple analysis to be able to see. So we are going to run an independent samples t-test. And so here's the import code, which I gave you in the hints. And then you had to do a little bit of research to figure out exactly how to do the t-test. So what you need is just a list of values for explicit and non-explicit. So what you need to do is create these popularity lists. I named them explicit and non-explicit, and what I did is I took the data frame where explicit is true, so this gives me a list of songs that are explicit, and then I just wanted the popularity. So this just gives me purely a list of popularity. And then I did the same thing with non-explicit. So let me just run this above so I can just show you what this looks like. So if you were to print out the explicit, you can see there's indexes here and then just popularities. So non-explicit is going to look the exact same, just with different popularities. And so with an independent samples t-test, what it does is you can just look through those lists and it'll determine if it's different, if those are significantly different from each other. And the reason why I had you not use the averages is because these tests are designed to work by just using the raw variables. So here's how you do it. This equation right here. You've got t-stat, comma, p-value equals t-test ind, and then you pass in your two lists, and then there's this equal variance argument that we assume is false. This will almost always be false for the purposes of this test. And then what I did is I just did an if statement. You don't have to do this. You could just look at the p-value and see what it is. But what I did just to remind me that less than 0.05 is significant, I just said if it's less than 0.05, we're going to print difference is significant, p-value is this, otherwise not significant. So let's go ahead and run that. Difference is significant, p-value is 0.03365, etc. So what we've learned from this is that the difference between our popularities of explicit songs and non-explicit songs is significant. That means we can't just discount it. We can actually assume that the popularities that are present in the data set are significantly different so that we can go back to our graph and we assume that this is not just a coincidence, that this is actually representative of real popularity. So I would say that this actually confirms what we were thinking based on looking at our graph. If our p-value were not significant, then that could be a reason for us to cast doubt on these findings and maybe tell our marketing director to give it a shot, but just be cautious because statistics is a predictive science. But in this case, because this is significant, we can see there's some differences here. My final conclusion would be do not focus on just explicit songs. I think we would risk losing money. Thank you for watching this solution, and I am hoping that this was helpful for you and that you're able to learn some basic statistics and data analysis in Python. Thank you.